A very good day to Dr. Omar. In this video, we from Group 1 will be presenting on the topic magnetic material and influence along with its application of electromagnets which are motor and maglev train system. Our group consists of me, Iqbal bin Najib.
Hi, my name is Yek Xinwei.
Hi, my name is Geam.
My name is Malik, Warit, Araf.
In simple words, electromagnetism was discovered accidentally in 1819. A Danish scientist named Hans Christian Ørsted found that a compass needle moves whenever a current is flowed nearby. You must be wondering, why is it important to understand the topic? Well, electromagnetism have a lot of real-world application. Some of them are as small as motor, while some are as big as a maglev train system. This means that an electric current could somehow cause a magnetic force. The opposite is also true, as magnet can also be used to generate electric current. Later in the years, the topic was discovered gradually with many laws appearing coming from names such as Biot, Savart, Ampere and Faraday. Understanding electromagnetism is essential to understanding the properties of light, its propagation through human tissues, and other important characteristics and effects which in the long run will help engineers to detect problems as well as avoid them. This will in turn help humanity to progress with more innovative engineers who will invent new products or even improve an existing one with the help of electromagnetism. Without further ado, let's jump into the theory behind it.
For the theory part, we will consider magnetic fields in material media. First, we'll discuss about the magnetization in materials. Magnetization is the density of magnetic dipole moments that are induced in the magnetic material when external magnetic fields is applied. A material's magnetic effects can also be induced by passing an electrical current through the material. The magnetic effect is caused by the motion of electrons around the nucleus and the spin of the electrons around its own axis. When there is no external magnetic field is applied, the dipole moment is randomly oriented. When an external magnetic field is applied, the dipole moment aligns with the magnetic field, so the total dipole moment is not equal to zero and the material is said to be magnetized. We can use chi-m, the magnetic susceptibility, which means the sensitivity of the materials to the magnetic field, or mu-r, the relative permeability, to classify the magnetic property of materials. The three major classes of materials are diamagnetic, paramagnetic, and ferromagnetic. While a material is said to be non-magnetic when the magnetic susceptibility equals to zero. The classification and the difference of the materials is shown. The material is said to be diamagnetic if it has very small negative magnetic susceptibility. It is paramagnetic if magnetic susceptibility is very small and positive, while for ferromagnetic, it has very large positive magnetic susceptibility.
One of the applications of electromagnetism is electric motors. In a simple motor, there are two major parts which are rotor and stator. These are the components of a motor. The permanent magnets provide constant magnetic field, and when there is a current flow through the coil, there will be an electromagnetic force induced according to the Fermi left-hand rule, and the coil will start to rotate according to the direction of force. Commutator rings helps changing the direction of current in the coil to make sure the same direction of force and maintain the rotational motions. For universal motor, the permanent magnets are replaced with copper winding in a specific arrangement as shown. When it is connected to DC power source, a constant magnetic field will be created by the field winding at the stator and the motor will work just like a normal DC motor. When it is connected to AC power source, an alternating magnetic field will be created by the field winding as the current flow are alternating, and the direction of current flow through the armature also alternating along with the current flow in the field winding, as they are in series. This makes sure the torque action always in the same direction with a motor rotational motions.
And I will talk about the second application of our group assignment, which is based on the topic of magnetic materials and influence. The second applications are maglev trains. Maglev trains are different from conventional trains because they do not have engines and they work with the help of the principle of magnets. There are three parts in the there are three main components in a maglev train: the electrical power source, the magnets attached underneath the trains, and the magnetic coils in the rail tracks. Right? Because of no friction, they run at a very high speed, and that is not found in normal trains. That is all from my side. Thank you, and I would like to ask my next teammate to talk about the conclusion of our assignment.
In conclusion, understanding the topics of electromagnetism is extremely important for engineers, electrical and electronics engineers in particular, to continue progress into the future towards Industrial Revolution 4.0 and further. Without proper understanding of the matter, there will be no invention of amazing systems such as the motor and maglev trains. Many other applications also exist closely to humans, and many more to come with new ideas coming from new engineers in the future. The topic is not necessarily just academic. It is a part of life, a knowledge which will be able to serve the people, the society, and benefit the nation. It is of great importance for humanity to continue moving forward and continue gaining knowledge for the good of everybody, not just themselves. Thank you and have a good day.